All right, guys. So, really quick, I want to just kind of go through this review for your test tomorrow. Remember, there will be 10 questions, and five of those questions will be on counting atoms in chemical formulas, in chemical equations, and also the law of conservation of mass. And then the other five questions will be on the evidence of chemical changes. Okay. All right, so first things first, I know it's a little blurry. We need to make sure that we understand how to treat all of these things. Um, so let me go ahead and go back. So this is a coefficient, right? So this came straight from an assignment that you did earlier. So this is a coefficient, and so we would mark that with this triangle right here. Okay. And let me see what's going on here. Order, bring it to the front. No. Anyway, so this is a coefficient. This is a multiplier for everything. Okay. This tells us that there are three molecules of this substance. These are subscripts that tell us that I have two carbons, four hydrogens, and two chlorines in one molecule of this substance. But this three then means that I have three of these. So I would then use this three to multiply times each one of these subscripts. So on the test, if they ask you how many carbon atoms there are, it is 3 times 2. If they ask you how many hydrogen atoms there are, there's 3 times 4. And if they ask you how many chlorine atoms there are, it is 3 times 2. Okay? So without that coefficient, if I were to just cover that coefficient up like this, then there would be 2 atoms of carbon, 4 atoms of hydrogen, 2 atoms of chlorine. But without that, there would be 6 atoms of carbon, 12 atoms of hydrogen, and 6 atoms of chlorine. Okay? All right. So you also may be able or have to identify reactants and products, and then be asked particular questions about how many atoms are in the reactants or how many atoms are in the products. Okay. So let's remember that these are the products. Anything, oops, wrong box. These are the reactants, and these are the products. Okay. So anything to the right of the arrow is produced during a chemical reaction. Anything to the left of the arrow is what we added. So this came from the lab yesterday. So the reactants in the lab were the baking soda, the calcium chloride, and then it says water here, but we used phenol red to get the same effect. And then what we produced in the bag was calcium carbonate, salt, a little bit of water, and carbon dioxide gas. So those bubbles that you saw in the bag inflating was that carbon dioxide gas being produced. So here we would type in the elements that we see. So we see sodium. We see hydrogen, H. We see carbon, C. So it's best to just start from the left and move to the right. Then the O is oxygen. And then the Ca is calcium. And then the Cl is chlorine. Now, we don't have to do these two because we've already identified hydrogen here and oxygen over here as well. So now we have to count the atoms, all right? So here, there's only one sodium without the coefficient, right? But there's two of these molecules. So the total sodiums here would be 2. The total hydrogens here are 2 because this multiplies everything, like I said in the last slide. And then I have 2 hydrogens here. So the total number of hydrogens on the left is 4. For carbon, I have 1 carbon here and no other carbons. So that would just be 1. I have 3 times 2 oxygen. So I have 6 oxygens over here and 1 oxygen over here. And that would be 7. For calcium, no coefficient, no subscript. So that's just going to be 1. And then for chlorine, 2 for a subscript, no coefficient, so this would be 2. And so when we add all of these up, you get 6, 7, 14, 15, 16, 17. Oh, I'm sorry, I forgot, my bad. This carbon should be 2. I forgot about the coefficient. Okay, look at me. I forget myself. So the total number of atoms should be 18. Okay, and just to kind of speed things up a little bit, guess what? It's the same over here. So this chemical equation is balanced. It follows the law of conservation of mass because the atoms on the left equal the atoms on the right. So this is kind of a sample question. It's not going to be on your test tomorrow, but it's an example of a question that you might get. It says a chemical reaction is represented by this equation. What is a product of this chemical reaction? So if it's asking for a product, then we're only dealing with stuff that's on this side right here, okay? So now we have to look in the answers to find anything in the answer that looks anything like what's in this box here. So there's no FeO, so it can't be A. There's no F by itself, so it can't be B. There is an O2 right here, and there is not Fe2O3. That's over here in the reactants. So your answer here would have to be C, okay, because that is the only thing in the answer choices that appears in the products. Here's another sample question. Which of the following is the balanced equation for the decomposition of hydrogen peroxide into water and oxygen gas? So the products have to be water and oxygen gas. So if we go through here, this does not have water in the products, okay? So we're not gonna, A cannot be the answer, okay? So we're gonna completely block this one out. All right, so now we need to make sure which, this is water, oxygen, water, oxygen, water, oxygen. So now we gotta figure out whether or not it's balanced. So here I have 2 hydrogen, 2 hydrogen, 2 oxygen, and 3 oxygen. So it can't be B. Here I have 4 hydrogen, 2 times 2. I have 2 hydrogen here. So this also cannot be the answer because they have to be the same. So here I have 4 hydrogen, 2 times 2. Over here I have 2 times 2 hydrogen. I have 4 oxygen, 2 times 2, 4 oxygen here. I have 2 oxygens here and 2 times 1, 4 oxygens here. So this one has to be the answer. Okay. All right. So evidence of a chemical change. Remember, these are the last 5 questions on your test. Clues that we're looking for to identify whether something is a chemical change are gas formation, and that could include bubbles, fizzing, smoke, or odor. Formation of a precipitate only occurs when you mix 2 liquids and a solid forms. Number 3, an energy change. So that could be an increase in temperature, a decrease in temperature, light being given off, or sound being given off. Those are all forms of energy. And then the last one is color change. Okay, so here's some examples. We have the gummy bear being put into this substance, and so you can see light, you can see smoke, so there's gas production. You can see light, so you know there's light being produced. There's most definitely an energy change because you can see the fire in there as well. And you can also see that the gummy bear is changing color. So that has 3 different pieces of evidence. In this clock reaction, you can see that this is really just a color change. This is a chemical reaction, and it actually goes back and forth between being clear and turning black. So we call that a clock reaction. This is an image that shows you the formation of a precipitate. We have a clear liquid inside the container. We have a clear liquid being poured into the container, and you can see this yellow solid that is forming inside the beaker. And then, of course, we have the glow sticks that are also chemical changes. And so here at the end, all I have put here at the end of the show are 3 videos that I've made that you should have watched already. that I went over in class, but I made videos of them as well that talk about how to count atoms and how we deal with coefficients and subscripts. There's a video that talks about the evidence of a chemical change. And then this one talks about the law of conservation of mass and chemical equations. So please make sure that you look through these videos. We want you to do the absolute best that you possibly can on the test tomorrow. So please take advantage of these review materials so that you can be successful. All right, guys, good luck on your test tomorrow. See ya.